Hey guys, so here is part 1 of the 8.5 notes. We are now going to be talking about the other two types of quadrilaterals for this chapter. It's going to be trapezoids and for kites. So make sure that you have already filled out the entire quadrilateral family tree, especially for trapezoids and kites. We're going to be using that basically to talk about the different properties and then use that to solve for angles and sides. So since a trapezoid is a quadrilateral, remember four-sided polygon, with exactly one pair of parallel sides. So you can see that in here. We can see that our bases are going to be parallel, and the parallel sides are the bases, okay? Now it's not always going to be the top and bottom because they can always flip this polygon to the side or anything, so just know which are the parallel sides there. The trapezoid has two pairs of base angles. For example, in this trapezoid, A and D would be our base angles, and the B or C are the second pair. The non-parallel sides are the legs of the trapezoid, okay? Now, the next thing is we can get a little bit more specific, and we talk about the properties of an isosceles, okay? So remember, we think about an isosceles triangle. That means two sides of that shape are congruent. They're exactly the same amount. So that's the same thing here. We can see that the two sides basically are legs. They are the congruent side. And then, of course, the base is going to be parallel. Remember, that's what the arrows represent. They're going to be parallel, okay? So here, legs are congruent. Each pair of base angles, so I'm going to do that too, each pair of base angles, they are going to be congruent as well. So those are going to be congruent, as well as these base angles are going to be congruent, okay? And then lastly, the diagonals can be congruent for an isosceles trapezoid. So those should be the three different properties for an isosceles trapezoid. Okay, now let's go ahead and do our first example. We're going to use the properties of an isosceles trapezoid. So here it says a shelf fitting into a cupboard in the corner of a kitchen, which actually I have something shaped like this in my house. That's interesting. In the corner of a kitchen is an isosceles trapezoid. So remember, that means the sides or the legs are congruent. That also means that the base angles, so K and N are congruent, and then M and L are congruent, okay? Now we don't really need to worry about the diagonals because all we're really finding are the angles. Okay, so here we already know that the measure of angle K is 50. Now we can assume what the measure of angle N is because that is congruent to K. So we can say the measure of angle N is going to be 50 degrees. Now, how can we find the measure of angle L and N? Well, here's kind of going back to the idea with parallelograms. That consecutive angles, now it's only going to be on the sides though. Okay, so we can see that K and N, when we do 50 plus 50, that only gives us 100, so that won't work out. But on the sides here, the angles will add up to 180 degrees. Okay, so it's basically along the legs here. Okay, so that means, let's say we're trying to find the measure of angle L. So to do that, we just have to do 180 minus 50. So measure of angle L plus 50 equals 180. So we subtract, then we can definitely get the measure of angle L is going to be 130 because we can subtract 50 from both sides. And so since L and M are congruent, the measure of angle M is also going to be 130 degrees. Okay, so now let's go ahead. We're now going to be talking about the mid-segments of trapezoids. Now that is actually one of the properties that we go to our trapezoids. So in the diagram, ABC is an isosceles trapezoid. So that means the legs are congruent, the base angles are congruent, and PQ is the mid-segment. So for part A, we're going to find the measure of angle B. So I'm going to go ahead and let's take that. We know this amount, and we know the sides are basically there. Okay, so to find the measure of angle B, we know for part A that the measure of angle D is 75 degrees. They give that to us in the picture. What we also know is that since D and C, those two angles, they are congruent, C is also 75 degrees. Now don't forget that along the legs, the angles add up to 180 degrees. They're supplementary. Okay? So how we're going to do this is that we can take our angle C, add it to our angle B, and equal it to 180 degrees. So I'm going to subtract 75 from both sides. I get measure of angle B equals 105 degrees. Okay, now let's talk about B here. B is now going to be talking about PQ, which is our mid-segment, okay? So this is one of the properties of a trapezoid. So the mid-segment is going to be 1/2 of the two bases, okay? So PQ is our mid-segment, and that's going to be equal to 1/2 the two bases here. So I'm going to just write that whole thing out so we remember. 1/2 base 1 plus base 2. Okay, so mid-segment is our PQ. That's what we're trying to find, 1/2. Our bases, remember, that's going to be our top and bottom. That's usually what's going to be. So it's going to be 25 and 35. Sometimes they can rotate these trapezoids so they're on their sides. Okay, now just plug this stuff into your calculator. So we do 1/2, or we do 25 plus 35. So add what's inside first, and then you're going to multiply by 1/2. So we do 1/2 times 60, which gives us 30. So that's going to be our mid-segment. Okay, make sure you watch part 2 of this video. We're going to once again do more with finding the mid-segment of a trapezoid.